Greetings everyone, this is Non-Expert here back again with another video. Today's video is going to be a continuation of the previous video where we are trying to solve how we would reverse a linked list. If you didn't check out that video, check it out. It's given in the link in the description below. But today the only difference that we're going to be doing is that instead of doing an iterative approach, we're going to go through a recursive approach. Now there are multiple videos which sort of follow through and try to help you understand those things. If you want to check those things out, you can. But I want to help you understand why exactly do you want to learn recursion, and this is like a really good place to start as well. Most people, most interviewers might just throw you a condition which would say that you need to solve this particular problem using recursion. If you don't know it, then it's going to have a lot of problems. The main part about the previous approach that we used was we had to sort of maintain a previous, we had to maintain a next, we had to maintain a current. All of those things, all that thing had to be contained. But if you sort of think about the recursive approach, you can sort of think about how would I, go to the last element and then move forward from there. Maybe that does not really make sense, but let's just look at recursion and the call stack frame as we sort of move forward. If I recursively call 1, 2, 3, 4, 5, what's going to happen is that once I hit null, and if my base condition is that print at null, we're going to be printing out 5, and then we're going to have the fourth element, then the third element, then the second, then the first, and so on and so forth. So let's just quickly look at what I'm talking about. Let's just say, hey, if head is not there, or if head.next is not there, um, then ideally what we want to do is we just want to return head. And let's just call it recursively. So we'll call reverse, oops, let's just call self dot reverse list, and just keep on going till the next value. So we do head dot next. That's basically it. So if we do print current and we return nothing at the end, we don't really need to do that. You can expect just 5 coming in and everything just being none, because you're just returning the value once you have head dot next equal to null. So you can see that over here, this node is 5. Yeah, and everything else is none. Makes complete sense. If I return current, it's going to return nothing but 5s. And that's just because current has been referenced and you're just returning it over and over again. So you're just returning 5 over and over again. But instead of returning current, what about we just return head.val? And we have current.val over here just so that we can look at things. So as you're recursively going, you still have the head next, the head value, right? So if you look at how the call stack is sort of going to go through, it's going to go through 1 when you have head as 1, you're going to call recursively to 2. When you have 2, you're going to call recursively to 3, so on and so forth till 5. 5 is going to be returned. So when you have 4, you're basically returning 5 at the same time. So in that sense, you have the current value, which is going to be 5, but you also have the reference 4. Now, all you need to do is you just need to update this pointer which I'm highlighting right now, to point towards nothing, because well, 4 does not need to reference the next value, which is 5. But what you want to do is you want to make sure that this 5 is now pointing towards 4. Because if we sort of swap those things out, what you'll see is that this thing has been removed and 5 is now pointing towards 4. So I'll just remove head.val for now. Actually, let me remove current and let's just do this, right? So again, all I'm sort of talking about is that we have the head, we have the current, which is going to be the current reference. And why don't we use that to move forward with our implementation? So what if I just say head.next.next, which is basically removing from 4, we are removing this particular reference and we're referencing it to ourselves. So let's just do head.next.next equal to head. So basically you change the reference to point towards yourself and you remove the present reference that you had to have nothing. Now, if I print current right now, and I just look at this from the first to the second, this thing is gonna like show me most of the things. And I think that right now we've sort of done as well with the solution. But we'll just look at the first two lines for now. So let's quickly do that. Let's just run this code one more time. I'm pretty sure that's going to run right now, but don't really look at that. What I want you to sort of notice is inside list node, what you've ideally updated right now is that you've updated 5, but you've also made sure that the reference is of the next reference which you have is of reference 4. And 4 does not have any more references. So if you sort of keep on moving forward with this, what you will sort of look at is that once you go to 3, you still have the same thing, the same reference. So you have 4.next of next, which is 4. 4 does not really have a next reference, so it's going to be none, but you're updating it to point towards 3. So that update happens and this thing sort of gets removed. And this thing goes iteratively, and you basically like get an essence of what's the pointer that you want to go at. The main trick of the problem is the return statements and how you use recursion. So again, what you've returned at the beginning is that you return when you're done with the entire recursive call stack, which is when you hit null, which is when you hit 5. You return that, and then you start updating references to the current value. And that keeps on going recursively as you sort of move forward, and that's basically it. So let's just go ahead and run the solution. Hopefully this should run fine, and it does. And let's just go ahead and submit this. And you can see like it's not the most fastest solution, and it's not the most optimal solution either. It's because of the call stack and how you sort of move forward with all those things inside the memory data structure that you have. The recursive call stack has its own space, which is not that high also. So you would probably want to look at, hey, this is not going to be the most optimal solution because you have to worry about the call stack and all those things. And our previous approach didn't really use any space complexity per se. It was over fun. But if an interviewer wants you to solve this through recursion, that's how you want to like go forward with it. And that's basically it. I hope that my justification was clear. If there was something that you didn't understand, do let me know in the comment section below. And that's it for today's video. Again, if you sort of like this video and if you have any comments, I would still tell you, do give a like and do subscribe to the channel. We are a discussion over here and we would love to have you on board with us. And if you've already subscribed, you're awesome. We all know it, and have an awesome day. Thank you.